right, so now we're going to look at special right triangle relationships, and we look at the right triangle relationships for a 45, 45, 90 and a 30, 60, 90. So let's start by drawing a 45, 45, 90. If we have a 90-degree angle and the other two angles are 45, that means that my two sides are going to be the same length. So let's call that x and x. By Pythagorean theorem, we can find the hypotenuse. So h squared is equal to 2x squared. That means h. If I take the square root of both sides, square root of x squared is x, and we get root 2 as the third side. Sorry, x root 2 as the third side. So I can redraw my triangle. X, x, x root 2. Well, x can be any number, and these ratios are always going to be the same. So let's look at the ratios. We know that these angles are 45 degrees. Okay, so that means that doesn't matter which 45-degree angle I pick, sine of 45 is going to be opposite over hypotenuse, opposite over hypotenuse. And of course the x's cancel. It doesn't matter what that length is because it's going to be the same value for every x. So that's 1 over root 2. Which of course I can rationalize the denominator as root 2 over 2. Cosine of 45, it's exactly the same because those two legs are the same length. 1 over root 2 over 2. And tan of 45, opposite over adjacent. So tan of 45 degrees is always equal to 1. So these are always true for a 45, 45, 90 triangle. The next special one is 30, 60, 90. So if I have a 30-degree angle, that looks more like the 60-degree angle. So let's put our 30 down here, and let's put the 60 up here. Oops. All right, so with a 30, 60, 90 triangle, now I'm going to tell you that there's special relationships, but we don't quite know what they are yet. So let's go to our calculator and look at the ratios. So I'm going to put in sine of 30 and get a half. Well, so if I put in sine of 30 and get a half, that means the ratio of opposite to hypotenuse is x and 2x. Because I know that sine of 30 is equal to 1/2. So this ratio, no matter how big I make the triangle, the ratio is always going to be 1 to 2. Well, I can find this third side now. So I'm going to label that one a for the adjacent to 30. So a squared is a squared plus x squared is 2x squared. A squared, 4x squared minus x squared is 3x squared. So that means that a is x root 3. So let's go ahead and change our a to be x root 3. That means that cosine of 30 must be x root 3 over 2x, same as root 3 over 2. Let's check that out. So square root of 3 divided by 2, cosine of 30, exact same number. So sine of 30 is a half, cosine of 30 degrees is root 3 over 2, tangent of 30 degrees, opposite over adjacent, 1/2 divided by root 3 over 2. That's going to give me, looking at this triangle, I would have x over x root 3 which is 1 over root 3. If I rationalize the denominator, that's root 3 over root 3. What I was doing before is dividing the sine value by the cosine value. Notice that that's opposite over hypotenuse divided by adjacent over hypotenuse. Well, the over hypotenuses cancel, and I end up with the same thing. Let's look at the 60-degree relationships. Sine of 60, opposite over adjacent, that's going to be x root 3 over 2x. So it's always going to be root 3 over 2. Cosine of 60, adjacent over hypotenuse, it's always going to be 1/2. And tangent of 60, is going to be the opposite over the adjacent. So tangent of 60, opposite over adjacent, x root 3 over x is root 3. So notice that sine of 30 is 1/2, cosine of 60 is 1/2. Well, if we're looking at the opposite angles from each other, that means the opposite and adjacent switch depending on which angle you're talking about. So sine of 30 equals sine of 60. Sine of 60 is cosine of 30. And there's a trick for remembering all of these. So one trick is you can just draw the triangles. So I'm going to come back up here. So here's one trick of just drawing the triangles. So opposite from 30 is always the shortest side. We can call that 1. And then hypotenuse is double, and in between, the adjacent side is root 3. So opposite the biggest angle is always the biggest side. Opposite the smallest angle is always the smallest side. Instead of using x, we can make those 1. So x root 2 turns into 1 root 2. If you just remember the 1, then you can use Pythagorean theorem to find the root 2. With the 30, 60, 90, you have to remember that the shortest side is 1 and the longest side is 2. And then you could find the root 3. The other way to do it is to think of a table of values. So if I think of my 30, 60, 90 angle, so 30 degrees, 60 degrees, 90 degrees. And then we think of sine theta, cos theta, tan theta. Well, all of sine and cosine are divided by 2. And then sine of 30. So opposite of 30 is the smallest side. 1, 2, 3. I put square roots over all of them, but square root of 1 is 1. So I'm just going to leave that a 1, square root of 2, square root of 3. And then I go 3, 2, 1, square root of 3, square root of 2, square root of 1 is 1. The way that I remember this is that 30 is the small degree. Opposite, so sine is opposite. Opposite of 30 is the smallest side. I get a 1 on top. Cosine is adjacent. Cosine of 30 degrees. When I have cosine of 30 degrees, that means my adjacent is the longest side, so root 3 over 2 is the longest. And then tan is the division of opposite over adjacent. So opposite over adjacent is going to be sine divided by cosine, so 1 divided by root 3, because the 2's are the hypotenuses. And then root 2 over 2 divided by root 2 over 2 is 1. Root 3 divided by 1 is root 3. So there's the table to remember. If you remember 1, 2, 3, 3, 2, 1, and put square roots all over all of them, or just thinking about short side, long side.